Welcome back to this week's Trimble Forensics Tech Tip Tuesday. This week, we're taking a look at the Trimble SX10 and what targets are best in different scenarios, and things you may want to consider to get fast, accurate measurements on your next scene. All right, let's get into it. So the SX10 is a revolutionary piece of technology. The marriage of high-speed laser scanning with an optical total station brought with it a bunch of new possibilities to the world of crash and crime scene mapping. Now, one of these possibilities is the ability to use the court-tested survey workflow to assist with point cloud positioning and accuracy. To do this, the targets we use with the SX10 are one of the most critical decisions on a scene. The best way I can sum it up is to think of your targets as the hook on the end of a tape measure. Now, have you ever tried doing precision work with a tape measure hook that's flattened, worn, or loose? Our targets are the same way. The quality of our targets will directly impact our measurements and the accuracy of our scene mapping. Now, one of the things that the SX10 excels at is speeding up our data gathering by having the ability to take reflectorless shots from the convenience of our tablet. During the instrument setup, it's usually pretty easy to find a reflectorless target to be our longest shot without having to go walking 300 feet downrange with the Prism. Power pole bolt heads, sign text, and other features are easy to find and make our longest shot, saving a lot of time walking back and forth when it comes time to shoot a check shot. But this comes with a few things we need to be aware of. Sometimes it's easy to get caught up in, wow, this is simple, and forget what's going on behind the scenes, leading to errors and bad data. Like most things, we need to know what tool to use when. Reflectorless mode may be perfect for one shot, but may lead to a large error in another. And the same thing goes for a Prism. To explain this, let's jump into Reveal. Here we have a two-car head-on crash that we want to map using the SX10. Now, to do this, we want to make a couple moves around the scene, using some arbitrary points around the scene as our common points. First, our backside will be a reflectorless shot on our speed limit sign. Once we have that one, now we put down a couple dots of paint on the pavement and shoot these as common point 1 and common point 2. Once we have documented everything we can from this station, we pack up and move to the other side of the road. Now, during setup number 2, we want to shoot 3 points and have capture converter in position. We begin by shooting our sign, and all's good there. But when we shoot our 2 CPs on the pavement, suddenly we get a lot of residual error. But why? To explain this, we have to look at how the SX10's laser works. From the moment the laser leaves the instrument, the beam begins to spread. Now, the SX10 has the smallest spot size on the market, which only is a ½ inch wide at 300 feet. This is more accurately expressed as an ever so slightly tapered cone. However, to illustrate it, we're going to use a cylinder for simplicity's sake. Now, when we take on a straight-on reflectorless shot, the light strikes the object and has a fairly uniform return path length. However, when shooting a point from a shallow angle, this creates an oblong laser strike. And since the instrument uses the first return signal, the first thing the light hits and bounces back is what's measured. So let's go back and look at our scene. The first time we measured the point, it was at a relatively straight-on angle. However, when we moved across the roadway, the crown of the road, along with the added distance, created a very shallow angle that caused the laser beam to strike the pavement in an oval shape, giving us a point placement that is not exactly where we want it to be. This is a great time to break out the Prism pole, change the target to Prism, and measure the point that way. Now, we have to consider the move to the other side of the crash scene. The sign that worked so well as a common point for the first 2 station setups now suffers from the same shallow angle effect. However, since this point is already 5 feet in the air, using a Prism is out of the question, and hopefully we have another point in the scene that we can use. Now, the same thing affects us indoors as well. Moving the SX10 down a narrow hallway is going to be difficult if we place points flat on the walls. For this, placing a small masking tape tail or a sticker bent in half may make things a little easier if there simply isn't enough room to maneuver, as is the case in most residential hallways. Or we can use the Prism pole and put a point on the floor and set directly over it on the next move. Now that we've talked about reflectorless targets, let's talk about using a Prism. Our Prism poles come with a bubble level on them that can be adjusted as necessary. Now, over time, repeated handling and wear may cause the bubble to become out of true and should be realigned. Many rods use a 40-minute vial, which means that if your bubble has moved just 2 millimeters to the side, it means the top center of your Prism set at 5 feet is nearly 11/16 of an inch off of center. And if our Prism height is set to 8.5 feet, just 2 millimeters of movement on the bubble will sway the Prism 1 3/16 of an inch. Now, while this may be statistically insignificant in terms of energy loss over a skid mark, it can cause major problems when we move our instrument. If we use that tall prism to place common points that are very close to our instrument, or even worse, in a very narrow pattern, we run the risk of introducing a considerable amount of error into a very precise system. Then, when we move, these errors are again reintroduced, and we can end up with a pretty large residual error. Now, sometimes circumstances dictate that one or more of these things has to happen. We work in a very uncontrolled environment, and very rarely are we allowed the luxury of textbook operating conditions. Now, the best way to minimize these effects is to keep our bubble level in trim, use common points that are further than your scene evidence, spread the points as close to 90 degrees as practicable, lower the prism height, and use a bipod to stabilize the prism on points that will be used for repositioning of the instrument. We hope this video has been useful in explaining the target types that you can use with your Trimble SX10. Now, if you've got something useful out of this video, give us a thumbs up and be sure to subscribe to our channel. If you have any questions or comments, we would love to hear from you as well. Stay safe, and I'll see you again next week on Trimble Forensics Tech Tip Tuesdays.